All right, so in this lesson, we're going to be talking about similar triangles. Now, before we get into the actual lesson, I quickly want to talk about what similar triangles are. So, before though we talk about what similar triangles are, let's remember what congruent triangles are. So, congruent triangles are triangles that have corresponding angles and congruent corresponding angles and congruent corresponding sides. So in this case, I have triangle ABC and I have triangle DEF. Now these two triangles are congruent because AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. And all three of their angles, corresponding angles, are congruent. Okay. Now let's talk about similar triangles. So similar triangles, they have congruent angles, but their corresponding sides are what we call proportional, okay? Or their corresponding sides have equal ratios. Now let's take a look at ABC. So ABC, I have a triangle with side lengths 3, 4, 5, whereas DEF, I have a triangle with side lengths 6, 8, and 10. Now, 6 divided by 3 is 2, 10 divided by 5 is 2, and 8 divided by 4 is 2. Now, since all of these ratios, their corresponding ratios are the same, they are all equal to 2, that means that the two triangles are similar. Okay. All right, so let's take a look at exercise 1. So we're gonna skip exercise A, part A, because you guys don't have tracing paper, but remember what I said about corresponding angles of similar triangles. They are equal. So angle C is equal to or congruent to F, angle A is congruent to D, and angle B is congruent to E. Okay. Now for part B, we want to solve for the missing side lengths of both triangles. So we have AB is missing, so we're going to call that X, and FE, we're going to call that Y. Okay, so we have to solve for X and Y. So let's start with X. So like in the last lesson, in the last homework, I believe you guys did have a question where you had to set up a proportion to solve for missing sides. We are going to do that again. Okay. So now to solve for a proportion, there are many different ways that you guys can set up a proportion, but one of the ways is to do corresponding side over corresponding side is equal to two other corresponding sides. So let's start, like I said, let's start with X. So the side that so X is in this triangle ABC. Now the side that corresponds to X in triangle DEF is 20. So we're going to do X over 20 is equal to, now we are given these two lengths, so we're going to use 7 over 14. Now you have to be careful of how you set it up. 7 is part of the same triangle as X is, so that's why it has to go on top because X is on top. 14 is the same part of the same triangle as 20, so that's why it had to go on the bottom. We're going to cross multiply. So 20 times 7 is equal to 14 times X. So we get 140 is equal to 14X. So X is equal to 10. All right, so let's find Y now. So we found X, so X is 10. So now we're going to do the same thing with Y. So let's start with 8. Now you could do Y over 8, that's fine. So I'm going to do 8 over Y. Now I'm going to use 7 and 14 again. Now I'm going to put 7 on top because it's in the same triangle as 8. And I'm going to put 14 on the bottom. So I'm going to do 14 times 8 and 7 times Y. So 14 times 8 is 112. So Y is now 16. All right, so we want to give a dilation of triangle ABC that would guarantee its image A prime, B prime, C prime is congruent to triangle DEF. Now for dilation, we need a scale factor. So to figure out our scale factor, We can do, so we're mapping ABC kind of onto DEF, if you will. So 14 over 7 is equal to 2. So our scale factor of 2. So if we dilate triangle ABC by a scale factor of 2, it would be congruent to triangle DEF because all sides would be the same. All right. All right, so let's take a look at the bottom. So we are going to talk about similarity transformations. Now, if you guys remember from our transformation unit, we did a lot of, I mean, we still do a lot. You guys do it on your weekly questions, but we did describing a sequence of transformations that would map this triangle onto that triangle using rigid motion. So either rotation, translation, or reflection. Well, this is kind of the same, except similarity transformations also include a dilation. Okay. So let's read our exercise and let's see what we have to do. So given that triangle ABC and DEF are similar with congruent angles marked, we're going to give a similarity transformation that would map this triangle onto that triangle. Okay. Now, obviously they marked the angles for us, but in general, if you have a hard time understanding what angles get mapped to what angles, remember the order of the letters matters. Okay, so A is going to map onto D, B is going to map onto E, and C is going to map onto F. All right. Now, there are probably many different ways that we can do this, different orders, but this is just one way that we can describe how to map this one onto this one. Now, like I said, like we set up here, similarity transformations have to include a dilation, also in combination with some rigid motions. All right. So I'm thinking the first transformation that we could do is a translation. So translate triangle ABC. Now, we are not in the coordinate plane. So we can't say, 5 units to the right, 5 units up. When we describe a translation in like space like that, we have to use a vector. And remember, a vector has distance and direction. Now, again, you can do this many different ways, but I'm going to say along vector BE to map point B onto point E. Okay. So once we do that, to get triangle A prime, B prime, C prime, I'm going to add that in there as well. Okay. So now once we translate it, so this is C prime, B prime, A prime. Okay. Now, somehow we have to get C kind of on this side, on this side, this side, on this side. So I'm thinking we have to do a somewhat of a rotation. So now our next step is rotate triangle A prime, B prime, C prime. Now we're going clockwise about point E. And then this is the angle that we're closing, about like a certain the degree that we're rotating it. So we're going to say to close angle C prime B prime F. Okay. So now when we do that, this to get triangle A double prime, B double prime, C double prime. Okay. So now once we do the rotation, we end up with that. So now it's time to do our dilation. Okay. So now we're going to dilate triangle A double prime, B double prime, C double prime with a center of point E and a scale factor. Now, again, there's 3 different ways we could do a scale factor. One of the ways that we could do a scale factor is df over A double prime C double prime. So remember, new over old. All right. And that is one example of a similarity transformation. Okay. So now let's look at the next page. All right, so in the following diagram, it is known that BCN and ACM are collinear, and triangle ABC is similar to triangle MNC. We want to give a similarity transformation that would map triangle ABC onto MNC. So we're doing a similarity transformation. So this includes a dilation. All right. Now, again, be very careful lettering. A lot of you are going to say, oh, reflection. Careful. We are trying to map A onto N, M, B onto N, and C onto C. So this one is going to go on this one. This one is going to go on this one. Okay. So I'm thinking, so remember, we're careful. We're trying to map ABC onto triangle MNC. So what I'm thinking we first need to do is a 180-degree rotation. Okay. So a rotation of 180 degrees, and we can go counterclockwise or clockwise. Doesn't matter necessarily direction with 180 degrees rotations, remember. 100 degrees of triangle ABC about point C. Okay. To get triangle A prime, B prime, C prime. Okay. So when we rotate it 180 degrees, we end up here. So this is C prime. C doesn't really move a whole lot, obviously, because it's the center. B prime. Okay. So now this is where we do our dilation. But be careful, we're trying to map ABC, A prime, B prime, C prime onto this little triangle. So it's going to get smaller. So this triangle is our new, and this bigger one is our old. Right? So now what we are doing is we are dilating triangle A prime, B prime, C prime with a center at C. with a scale factor of, now again, there's 3 different ways that we can describe our scale factor. I'm going to say a scale factor of mn over a prime b prime. Okay. All right, so let's look at exercise 4. So again, we are going to do some type of similarity transformation, but this time we are in the coordinate grid. Okay, so let's take a look at A. So what is the scaling factor needed to dilate triangle ABC so that it is congruent to triangle DEF? Now, we actually can count the units for this. It is not like general, it's not just like a ratio. So let's take a look at AB and let's take a look at ED. So let's count the length of both. So AB has a length of 1, 2, 3, 4. And ED has a length of 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6, 6. Okay. So we are trying to dilate this one. So ABs are old, EDs are new. So the length of ED over AB. So our scale factor is 6 over 4. So our scale factor is just 3 over 2. Okay, so now we want to specify a similarity transformation that would map triangle ABC onto DEF. So one of our transformations is going to include a dilation, but the other is going to be some type of rigid motion. Okay? Now I'm thinking the first thing that we need to do is reflect triangle ABC over the y-axis. Right? So when we do that, our triangle ends up here. Okay. So now we need to do our dilation. Now, since we are in the coordinate plane, we are using points in the coordinate plane to specify our center. So we are dilating triangle A prime, B prime, C prime with a scale factor of 3 over 2 with a center of point 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 3, negative 7. Okay. And that is going to map A prime, B prime, C prime onto EDF or DEF, right? All right, so let's take a look at exercise 5. So in the diagram below, A, B, and C are collinear, as well as A, D, E, and E. It is also known that BD is parallel to CE. And we want to give a dilation that would map triangle ABD onto ACE. Okay. So we can, so our center is point A. Now, scale factor, new over old. So again, there's 3 different choices that we could do. We could do AC over AB. They're trying to get this one over this one. So ABDs are old, ACEs are new. We could do BD or CE over BD, or we could do AE over AD. The choice is really yours. I'm going to do CE over BD as my scale factor. Okay. Now let's take a look at the next one. So circle the proportion that is incorrect based on the fact that triangle ABD is similar to triangle ACE. Now I'm going to kind of give a little disclaimer here for these types of questions. The only way that you are going to be able to answer these questions accurately and in a way that makes sense is for you to really draw these out and to kind of go through each choice. I will be very honest, these questions are really hard for me to like teach you how to do. I can teach you kind of a strategy to help you, but you really just have to think. Okay. So that's why I'm going to draw it out on a separate sheet of paper, and we're really going to go through each of these choices to kind of figure out which one is incorrect. Okay. Okay. So we have triangle. What do we have? Triangle ABD is similar to triangle ACE. So the first little strategy that I have for you is to number your letters here and also on your diagram. Okay, this is going to help you kind of figure out which sides correspond to which sides and to kind of like see like the congruence stuff and like whatever. All right. So let's take a look at the first one. So the first one is AC over AB is equal to CE over BD. So AC over AB is equal to CE over BD. Now what we're really looking for is which one do these match up, okay? So AC is 1 and 2, okay? And AB is 1 and 2. Now this one is from triangle ACE. This one is from triangle ABD. Okay, and they are corresponding sides, so they do match up. Now CE is 2, 3, and that is from triangle ACE. So we have both sides from triangle ACE, so those match up. And then we have BD here, which is 2, 3. So 2, 3 over 2, 3, so those match up. And triangle ABD. So we have ABD and ABD, so those match up. So since everything matches up, that one is true. We are looking for the incorrect one, so that is not the answer. Okay. Now let's take a look at the next one. So we have angle A over the measure of angle ABD, and then we have the measure of angle A over the measure of angle ACE. Okay. Now, in the measure of angle A and the measure of angle A, those are congruent angles. Okay, so 1 and 1. Now, ABD is this angle, and ACE is this angle. So since those are also congruent angles, those match up. So that is not our answer either. All right, so let's take a look at 3. So we have AD over AE is equal to AC over AB. Okay, so we're going to do the same thing like we did up here. So AD is 1 and 3, and that is from triangle ABD. AE is 1 and 3, so that's from triangle ACE. Now let's look at this next side. So those are corresponding sides, so that works. So now let's look at AC. So AC is 1 and 2, and that is from triangle ACE. Now we have a problem here. AE is from triangle AC and it's on the bottom. Since this side is from triangle ACE and it's on the top, it's supposed to be on the bottom. Because AB, now even though these sides match up, they're from two different triangles. Do you see how in this one, ABD, both sides from ABD are on the bottom and both sides from ACE were on the top? Since the one's on the bottom, one's on the top, that is not a correct way we can set up this proportion. So that is why choice 3 is our answer, is the incorrect proportion. Okay. Now let's take a look at the last choice just to be safe. Now we have AEC, this one over ACE. So that's from triangle ACE, triangle ACE. That is 1, 2, 3. Wait, 1, 3, 2. 1, 2, 3. So that's okay. We can have triangle over triangle, the same triangles. So let's just see if these match up with this. So ADB is 1, 3, 2, and ABD is 1, 2, 3. So since we have 1, 3, 2, 1, 3, 2, 1, 2, 3, 1, 2, 3, since they match up, that works. So our answer, like I said, is number 3.